Hello everybody, my name is Tryphon Mabanza. I'm a student in Master of Science Advanced Engineering Materials. Today I'm going to talk about UV-VIS spectroscopy. So the first slide is defining UV-VIS spectroscopy, which is mean ultraviolet visible spectroscopy or spectrophotometry. UV stands for ultraviolet and VIS stands for visible light. UV and visible light are both parts of electromagnetic spectrum. Ultraviolet light has a shorter wavelength than visible light. Also, UV waves are invisible to the human eyes. Visible light is defined as the wavelengths that are visible to most human eyes. The principle of UV visible spectroscopy is based on the absorption of ultraviolet light or visible light by chemical compound. So here you can see the schematic of how the inside of a UV-VIS spectroscopy machine looks like. We have the source of light, which could be ultraviolet light or visible light. And here we have the sample, the cuvette that will contain a solution. And here is the detector. So the light of UV-VIS can go to the sample, and the sample that will absorb much light, it means that compound that is too much in that sample. So what is the function of UV-VIS spectroscopy? The UV-VIS spectroscopy can perform two functions: quantitative function or qualitative function. About quantitative function or quantitative technique, UV-VIS spectroscopic data can give quantitative information of a given compound or molecule. It helps to determine the amount or concentration of a non-chemical substance, analyze concentrations, or the chemical conversion of a component in solution or as a solid. It can determine the amount of ion present in a liquid or determine the amount of a quinine in a series of dilutions solutions by measuring fluorescence intensity. So here it means by quantitative technique, the UV-VIS spectroscopy will determine the amount of a substance in a sample and how if that compound absorb too much light. About qualitative technique or qualitative function, UV visible spectroscopy can identify of unknown substance and impurities. UV-VIS spectroscopy is used in combination with other qualitative techniques to build up a picture that enables the absolute identification of an unknown. This is frequently achieved through comparison of the spectrum of a solution of the unknown with a reference spectrum. The amount of qualitative information available is limited. It means that UV-VIS spectroscopy provides more the quantitative technique, but the qualitative technique is very limited. Operating mode of UV visible spectroscopy. It means the principle how the machine works. So it performs the quantitative function by measuring how much a chemical substance absorbs UV or visible light. Visible light means photons that pass a sample with respect to desired optical energy range. In the electromagnetic spectrum, the UV-VIS region energy is between 1.5 to 6.2 electron volt, which relates to a wavelength range of 100 nanometer to 800 nanometer. 100 to 400 nanometer is for UV light. Wavelength of UV light is less, so the frequency is higher. That is mean short wavelength, higher energy. And 400 to 800 nanometer for visible light. So the wavelength of visible light is higher, so the frequency is less. Otherwise, higher wavelength, shorter energy or shorter frequency. The spectrophotometer will direct a known amount of light through a cuvette filled with solution. To obtain a reading, A detector will measure the amount of light that is absorbed by a solution. The more a material absorbs light at a specific wavelength, the higher the concentration of the known substance. In other words, the more compound molecule in the sample cuvette, the more absorption. The absorbance depends also on what chemical compound is placed into the sample cuvette chamber. The sample will be placed in the cuvette for measurement. For the first run, we must do a blank solution scan and auto-zeroing. This means that both the blank reference cuvette and the blank sample cuvette will just contain a solvent, so the solvent could be water. Fill both cuvettes, reference and sample cuvettes, with the solvent to rinse them. Put the cap on them and shake. Dispose the water away into the waste beaker. Clean the transparent sides of the cuvette with a tissue to make sure that there are no fingerprints. Like in this image, the person is cleaning the outside of the cuvette before to insert it into the machine. Open the lid of the sample chamber. There are two cuvette holders. Label one as blank and another as sample. Place the cuvettes according to their respective labeled places, then close the lid. Do auto-zeroing. There is a manual next to the machine. You may refer to it anytime. Turn on the machine and wait for it to initialize. Press the button 2 on the control panel. This is to access the spectrum. On the data displaying screen, we will see the scan range. It is where we must set the range from 800 nanometer to 400 nanometer. The absorbance value can be determined is from 0 to 1.5. Make sure that the two raw data on the screen are well imputed. Following the manual, press Auto Zero. Auto zeroing is completed when the spectrophotometer will beep a sound. Take out only the sample cuvette, discard the solvent in it to the waste beaker. Rinse it with the solution to be measured, not with the solvent again. Ensure the solution we are measuring is not diluted with the solvent. Now, fill the sample cuvette to 4/5 with the solution, clean its transparent sides with a tissue, place it into the sample holder and close the lid. Press the start button on the control panel. The line will trace from 800 nanometer to 400 nanometer. Press F1 to zoom the peak. The spectrum will be fully displayed on the screen. Press F3 to order scale. Press Return to change the tab. Press F2 for data processing, followed by the button 3. You can see the maximum absorption wavelengths and absorbance value for the compound being measured. Like here, for this compound, the absorption wavelength is at 591 nanometer and absorbance value is 0.424 nanometer. Press again F2 to print out the spectrum, which is the data sheet to see the following data, the peak, the maximum absorption, and the absorbance value corresponding to it. Now here is the application and limitation of UV visible spectroscopy. About application, it's just in relation where the technique of UV visible spectroscopy can be used or can be applied. So this technique can be applied in traditional chemistry, in life science, in microbiology, in food and agriculture industry or laboratory, in material science, in optical components, in pharmaceutical research, pharmaceutical industry, laboratory as well, in petrochemistry, in cosmetic industry, and in astronomy. The goal is just to determine the amount of a compound in a solution, in a mixture of compound, to know which compound is at high level. And the compound which is at high level is that compound that will absorb much UV or VIS visible light. What are the limitations of the UV visible light spectroscopy? UV-VIS spectroscopy is not a useful tool for qualitative analysis of organic compound, because the spectra generally show only a few broad absorption bands. Waste of time. It means the time it takes to prepare this, to set it up and to use it. You must clear the area of any outside lights or other outside contaminant that could interfere with the spectrometer's reading. So all these processes take too much time. Small bits of outside light of vibration from a small electronic device could interfere with the results. So it means we have to be careful when using the machine. So make sure that you are doing the process in a quiet place, because the vibration of all the machine can change the result. They can change the structure of the compound, and when you place the compound inside the machine, you can maybe obtain a wrong result. So this is the last slide, which is in relation to the references, the sources I used to write my slide. We have a crystal Finlay. Difference between spectrometer and spectrophotometer is an article which is online. Another an article from Edinburgh Instrument, UV-VIS spectroscopy, available online. Pavan, Rajan and Andrew. The title of article is UV visible spectroscopy and is online. So thank you very much for watching this video. Bye.